Today we're going to be talking about the surface area and the volume of an actual sphere. So let's kind of talk about the different parts of a sphere. Now I'm going to talk about it orally. You may want to jot some stuff down on your own. So a chord kind of looks like this. This is a chord and it's a segment that connects any 2 points on a sphere. So it doesn't necessarily have to go through the center, but it does need to connect 2 points of a sphere. A diameter is a chord that connects it goes through the center and connects one side to the other, going through the center of that sphere. Now the center of the sphere is really like the center of the circle, but since the sphere is round and circular, it's like a ball, it's going to be the very center of that ball. The radius is going to stem from the center of the sphere and go to the outside. Just like before, the radius is half the distance of the diameter. Okay, a tangent is the line that's going to sit kind of next to a sphere. Okay, now let's talk about a couple of other things when we talk about a sphere. So when we talk about a sphere, there's a thing called a great circle, and that's the circle here that's going to be existing at the center. So that's going to be the largest circle is at the center. So when you get the circle at the center, that's your largest circle. And then the poles are the endpoints. So these poles are the endpoints of your diameter, and the endpoints of those diameter are on the great circle. So let's go ahead and let's take a look now at how we actually calculate out the area. So taking a look at the surface area of a sphere, here's the area where the formula we're going to use. So to get the surface area of a sphere, we have 4 times pi times r squared. Now there is no lateral area for a sphere because we don't really have any bases because it's all round. So all we can do is calculate out the surface area, which is 4 times pi times r squared. Now how do we get a volume of a sphere? The volume of a sphere is going to be 4/3, so we're going to use the fraction 4/3, which is really 4 times everything divided by 3 times pi and then times r cubed. You could just take 4 times pi times r cubed and then divide it by 3 if you wanted to do that as well. So let's go ahead and let's take a look at number 1. So for number 1, we have, or number 3, whatever you want, I guess. So for number 1, we want to find the surface area of a sphere. So when you find the surface area of a sphere, we notice that it's 6 centimeters for the radius. So all we have to do is plug that into that formula that the surface area is 4 times pi times the radius squared. Well, the radius given to us is 6, and then that's going to be squared. So in your calculator, you're just going to type 4 times pi times 6 squared. And that's going to give you 452.39 centimeters squared. So that's your final answer for number 1. Taking a look at number 2, we want to find the surface area of this sphere. Now this sphere we're given the diameter is 22 feet. So to get the radius, we need to divide that by 2. So 22 divided by 2 is 11. So the radius of this sphere is 11 feet. So now we want to calculate out the area. So we're going to do 4 times pi times our radius squared. So really that's 4 times pi times 121. And then you can type that all into your calculator and you get 101,520.53 feet squared. And that's your final answer for number 2. Let's take a look at number 3. That is not the number 3 that you guys have, so we'll just add a page. There it is. Okay, so taking a look at number 3, find the volume of a sphere that has a radius of 8 centimeters. So we want to find the volume. Now remember that volume is, 4/3 times pi times the radius cubed. So the radius is 8, and then we're going to raise it to the 3rd power. So when you type that into your calculator, what you're going to have to do is 8, and then there's a little key that looks like this. That's how you get an exponent, and then you're going to have to put in 3. That's how you're going to get the volume. So we're going to do 4/3 times pi times 8 to the 3rd power. I would suggest typing that in your calculator right now yourself. You want to make sure you are able to do it. Okay, if not, come talk to me and I'll help you locate it. So stick with whatever calculator you're going to use for the future. And then you end up getting 2,144.66. Now we're talking about volume, so our centimeters are going to be cubed. So let's now talk about a hemisphere. Okay, That's cool. Let me just check here and see if there's that slide there. Nope. Okay, so let's talk about a hemisphere. I'm just going to add the slide. So when we're talking about a hemisphere, I should really check these over, huh? So we want to talk about the surface area of a hemisphere. So for the surface area of a hemisphere, that's basically a half of a sphere. So if we have a half of a sphere, then what we're going to have is 4 times pi r squared divided by 2 plus pi r squared. Now, Miss Hummer, that doesn't make any sense. Well, let's take a look at this first part here. So it makes sense that if we have half of a circle, that the surface area is going to be half the size, right? That would make sense. So this is going to become 4 pi r squared. But where is this guy coming from? Well, think of it this way. If you cut a sphere in half, all of a sudden we have that great circle on the bottom. And that great circle is kind of serving as a base. So we need to add on the area of that great circle so that it's counted as part of the surface area. Now, to get the volume of a hemisphere, so the volume of a hemisphere, can I just put hemi like the car? I think you guys can handle that. So the volume then is also going to be 1/2 times 4/3 times pi r cubed. So we're literally just taking the volume and cutting it in half. So you could leave the formula like that, or if you wanted to, you could also write it as 4/3 pi r cubed, all of that divided by 2. You could also write that as well. So let's take a look at number 4. So we want to, oh man, it's not there. Okay, so taking a look at number 4, we want to find the surface area of a hemisphere. So we have a hemisphere that has, I think I had it earlier, didn't I? A radius of 2.8. So we're going to plug it into our surface area formula, which is 2 times pi times our radius, which is 2.8, quantity squared, plus pi times our radius, which is 2.8. So really, you can just plug this into your calculator. You can do 2 times pi times 2.8 squared plus pi times 2.8 squared. And then what you should do, practice it on your own. Make sure you get the right answer. You should get 73.89 centimeters. And again, it's going to be squared because we're talking about the surface area. If you didn't get that, come check with me. Let's make sure you're plugging it in correctly. I mean, not incorrectly, but you're plugging it into your calculator correctly. There we go. Let's take a look at number 5. Find the volume of a hemisphere with a radius of 6 meters. So we're trying to find the volume. So I'm going to use that second formula where I do 4/3 times pi times my radius cubed. My radius is 6. Remember how you plug that cubed into your calculator. Let me help you if you need it. And then what I'm going to do is I'm going to take all of that and divide it by 2. So what I did in my calculator is I typed this in. I did 4 divided by 3 times pi times 6 to the 3rd power. And I got 904.78. And then I'm going to take that and I'm going to divide it by 2. So 904.78 divided by 2 is going to give me 452.39, and then meters cubed for your final answer. Because remember, when we're talking about volume, our label is cubed. Again, make sure you know how to punch this into your calculator while you have the video to check it with. Let's take a look at number 6. It says the stone spheres of Costa Rica were made by forming, did I not hit it? Okay. Oh, that looks horrible. That's hilarious. Boulders into spheres. One of the stone spheres has a volume. So our volume is 113,097.34. What is the diameter of the stone sphere? Okay, so we need to set this equal to our volume. So it's an entire sphere. It's not a hemisphere. So what we can do is we can use just the volume formula that you did on the front side of your note sheet. So what we're going to do is I want to get r cubed by itself. So I need to divide by 4/3 pi. So to keep it true, what I'm going to do is I'm going to divide by 4/3 pi in parentheses. So in my calculator, I'm actually going to type parentheses. So I have 4/3 pi. So then I'm going to have 113,097.34 divided by, and then in parentheses, you're going to put 4/3 pi. Make sure you put the parentheses there so your calculator knows to divide by the whole thing. So then you end up getting that r cubed is equal to 27,000. Now, this gets really complicated because we need to take the cube root, which is really, really, really confusing. So here's how you're going to do that. When you take the cube root, what you're going to do actually in your calculator is you're going to take 27,000 and you're going to use that little caret key I told you about for the exponent, and you're going to raise it to the parenthesis 1/3 power. So for example, if you were to take the square root, that's the same as raising it to the 1/2 power. So to take the cube root, that's the same as raising it to the 1/3 power. So I'm taking 27,000, then I'm doing that little caret key and raising it to the parenthesis 1 divided by 3. Now I want you guys to actually try this on your own so you make sure you know how to do it moving forward. So then you end up getting that r is equal to 30 inches. Okay, well, r is equal to 30 inches, but the question actually asks us for the diameter. So to get the diameter, we need to take the radius times 2. So we're going to take the radius times 2, so you end up getting 60, and then your label is just inches because we're talking about a line. We're not actually talking about an area or a volume. So that concludes your note video for today. Go ahead and show me your completed note sheet when you're done. Thanks for listening.